Hi, this video is an introduction to the periodic table, and I'm following the order of Chemistry, the Central Science by Brown, LeMay, Burston, and Murphy. So the periodic table is something that probably you've seen before. It finds its origins in the late 1800s. You remember Dalton in the early 1800s suggested that things reduced to atoms or individual components. And most of these elements appear in compounds in nature, so we're not aware naturally that they can be broken apart into atoms. But as the 1800s went along, chemists began to break compounds apart, and I think like from 1830 to 1860, the number of known elements doubled. And so a guy named Dmitry Mendeleev, and then also he's a Russian, and also in Germany, a guy named Lothar Meyer, pretty much at the same time began to recognize that there were patterns among these elements, that as the atomic weights, as they called it, as the atomic weights of these elements got bigger, it's like they went through the same properties over and over again. We call that periodicity, that there's a kind of a, and we've, in the modern periodic chart, we have these rows or periods where we basically see that the same characteristics repeat themselves, you know, for example, in 8s here in row 2. These 8 then repeat the general characteristics in the next 8, and so forth. And so Mendeleev was actually able to predict, for example, that there would be an element, gallium here. He didn't know what it was, but he predicted its existence, and I believe indium as well. He predicted that they would eventually find these elements with similar properties to aluminum, just because of the periodicity of the chart. He did really well. He intuitively came up with a pretty good chart. Well, of course, 150 years later, chemists have a really, really good chart. And we've gone well beyond uranium, which used to be, you know, at 92, used to be, you know, like, wow, uranium. But we've gone way beyond that in exploring the periodic chart. So this is your friend. Get used to your friend here. Periodic chart is your friend, and you'll be spending a lot of time with it if you go forward in chemistry. Some just general patterns about the periodic table. So the rows are called periods. That is, these rows are called periods because they're periodic. They do the same thing over and over again in terms of general characteristics. Then the columns are called groups. You know, so we have group 1, group 2, group 3, group 4, group 5, group 6, group 7. You'll notice that we've stuck some stuff in here in the middle. You'll find out eventually why these are stuck in the middle. And then these at the bottom are stuck in here. We'll figure out why, again, as we get into the atomic structure in later chapters. So the columns are called groups, and the rows are called periods. Elements in the same group, that is in the same up and down, demonstrate similar characteristics. Elements on the left of the chart and in the middle are metals. So that is to say, these are metals over here, and then these are called transition metals here in the middle. And then the ones over here are non-metals. Well, you can see kind of a step going down here where the ones around this step, the ones that are kind of a different color, boron, silicon, germanium. These silicon and germanium are semiconductors. You know, so the metals are conductors, non-metals are not conductors. These are semiconductors. They're also called metalloids, not quite metals. You know, they're somewhere in the middle. The elements on the left and in the middle are metals, and they tend to be solids. They are solids at room temperature, except for mercury. And because some of these elements are really old, they have symbols that are based upon Latin. So Hg doesn't look like mercury, but it is. It's from the Latin for mercury, because mercury's been known for a very long time. And so we just have to deal with it. Of course, you know, it wasn't English people who invented the periodic table. Mendeleev was Russian. Meyer was German, you know, so we didn't get the right as English speakers to decide what letters go for the elements. And especially the older the element, the longer it's been known. If it's been known from ancient times, probably it has a Latin-based symbol. Anyway, so mercury is the only metal that is not solid at room temperature. Mercury, of course, used to be used in thermometers, which you don't anymore, because if mercury gets in your body, it's there to stay, and it's not good. It's poisonous to the body. You might have seen the most recent, was it The Mummy? I can't remember. Tom Cruise movie. They put mercury in her body to keep her from being able to use her powers. Okay, it's kind of scientific, or not. Okay, so on the right side are non-metals, as I said. And then metalloids are along that step line. So those are some of the general patterns. So we end with some of the group names. So these are some of the group names that exist. Group 1 are the alkali metals. Group 2 are the alkaline earth metals. Group 6 are called chalcogens. Group 7 are called halogens. You might have heard of halogen lights. Anyway, and then Group 8 are the noble gases. Group 8 are at peace with the universe. So to go back to the periodic table, Group 1 or column 1, these are the alkali metals, and then these are the alkaline earth metals, and then we have the chalcogens in Group 6, and then the halogens in Group 7, and then these are the noble gases, which are completely stable. And there you have it. The periodic table, a brief introduction.